Hi guys, and welcome to this other video. I hope you guys are doing great. So today in this video we are going to do the task 2 regarding our SD-WAN setup. So in the previous video we did task 1. In the previous video we talked about we introduced FortiGate SD-WAN, where we discuss about the following objectives. So we discuss about what is SD-WAN, how it works. We talk about use cases. So one scenario where a company have like a company has a headquarter and branch offices, and another scenario where the company have only a headquarter, and the decision making about ISP that is going to be used will depend on the type of data that they want to access on the internet. So we also talk about the prerequisite to set up SD-WAN. We talk about the components of SD-WAN as you can see here, zone members and SLA performances. So today we are going to talk about SLA performances and rules. So after those explanation, we did the following activities, so the following tasks. So setting up SD-WAN. So we did the following tasks. So the link to that previous video will be mentioned on the description of this one. So today in this video we are going to jump on task 2. So task 2 here is going to be setting up SLA performance and SD-WAN rules. So we are going to jump directly on our FortiGate device and proceed. But before we proceed, what I noticed is that in the previous video I did not explain how I did to set up my two ISP, to bring my two ISP on the virtual FortiGate here on my GNS3, right? So actually on my workstation, if you check here on my workstation, you will see that I'm connected. So here you will see that I'm connected on two different internet connection, right? So I have one that is Wi-Fi and the other one is wired network. So actually, to set up this, you need to here on your GNS, on your VMware workstation, here is where you need to add network adapters. So the network adapters that you are adding here on your GNS3 VM, you need to make sure that behind those network adapters, you have created a bridge network that is linked to one of your physical network interface cards on your workstation, right? So to create this, as you can see here, I have like 3 interfaces here, 3 network adapters on my GNS3 VM here. Each of these network adapters is connected to a VMware virtual network adapters on which I've linked or I've bind a physical network adapter of my workstation. So to do that, you need to go here under let me close this. On your GNS or your VMware workstation here, you need to go under edit. Then you select the virtual network editor. So here on the virtual network editor, you need to go under change settings to proceed. So here on this interface, you notice that by default, when you install your VMware workstation, all the physical adapters, the physical network adapters that are actually on your workstation, all those physical network adapters will be bind on the virtual VMnet 0 virtual network card. This is a virtual network card of type bridge, right? So if you have, like in my case, I have a wired network and a wireless network. So what I did here was, from here when you select the VMnet, which is of type bridge or auto bridging here, you would need to go here under automatic settings. So from here under automatic settings, you will see that by default all your network interfaces on your workstation are bind on this card, on this virtual card. So you need from here to uncheck, you need to uncheck the adapters that you want to use them for creating a new bridge virtual network adapter. So you can see that from here I uncheck like three of my adapters. So those three, I was then able after to create a new virtual network of type bridge and bind my physical network. So you can see that I have like two. This is the wired network interface cards. So I have two wired network interface cards. So I was able to uncheck them from the auto bridging. Then I could create new network cards binding these physical network interface cards to those virtual networks. So that's how you need to create individual network. So to create network, you just come here after removing the physical card from the auto bridging. You need to come here and do add network. Then when you do add network, you will select from the virtual network adapters that are being provided by VMware Workstation. Then when you will select, you will now bind the physical interface to that virtual network that you are actually creating. So that's how I did to create this separate bridge network. So now I have like three separate bridge networks. This one receive internet connection from any wireless. So my wireless my wireless cards are actually on this network. So if I get to connect on the internet through wireless, so all the devices that are in VMware Workstation here who are connected to my VMnet will get internet from the wireless ISP that I'm using on my workstation. Then if anybody is connected to a wired network, that will be the same. So here what I did is to create these virtual networks from here. Then here on the GNS3 VM, on my GNS3 VM, I could add those virtual network adapters. As you can see, VNet, this is the default network adapter that is added as bridge. And you can see that by default, when you just select bridge, it is bind to VNet 0, because the VNet 0, as I said, is the auto bridging which gathers all your physical network adapters on your workstation. So next, I have another network card which is bind to VNet 1, which is also of type bridge. And I also have VNet, the third one, which is also bind to VNet 2, which is also a bridge. So now what I did after doing this, when you power on your workstation, here now on your diagram, what you do is, if you select the cloud object, so if you select this cloud object here, and you decide to use it on your GNS3 environment, what you are going to do now is, from here, if you right click and select configure, from here you will see that internet interfaces that you have. You see you have now three internet Ethernet interfaces, because this cloud object is actually being used on your GNS3, which is also using three Ethernet interfaces. So now from here you can easily select each of these interfaces, then connect it on your device or your firewall like me. So from here what I did was exactly as I just explained. So I could connect my Rogers with my wireless. So Rogers is actually entering in my wireless network, and the Bell is the wired network that I actually have on my workstation. So that's why I have these two interfaces on my FortiGate, and that's why from here on my GNS3. So that's how here on my SD-WAN I can configure. I was able to add those ISP, as you can see. So I just wanted to explain that part, because in the previous video I didn't explain. So maybe some people will see the previous video and they will try to implement it on their lab, and they will not be able to set up that part. So that was how I did it. So now let's jump actually on the task 2. So we'll start with load balancing algorithm. So for people who watched the previous video, so the link, as I said, is in the description of this one. So for people who watched the previous video, you've probably noticed that when we finish configuring, adding our network or our SD-WAN members, we didn't configure any performance SLA, we didn't configure any SD-WAN rule. But you could see that depending on the traffic that was generated on this workstation here, we were able to, the traffic was automatically shared to the two SD-WAN members, right? So you could see, for example, for volume, you could see that this is the volume that is managed by Rogers, and this is the volume managed by Bell. And also here under the number of sessions, you could see that the sessions were like shared, automatically shared without us having any impact. So you could see that this was automatically shared. The sessions were automatically shared on the two FortiGate device. So how does this work? So this is because here under SD-WAN rules, by default, remember the SD-WAN rules here works like the firewall policies, here. So here, if I go back on the SD-WAN, here the SD-WAN rules, by default, if you don't create any rule, all the traffic will be routed through this implicit rule here. So there is an implicit rule here, and this implicit rule have some criteria on how traffic is being redirected to each of the ISP member or each of the SD-WAN members. So let's just double click here to see what are those criteria. So the default criteria here, the default criteria for load balancing algorithm is source IP. So what does source IP says? It says traffic is divided equally between members. Sessions that start at the same source address use the same route. So like if, for example, this webtem1 initiates any traffic to any destination and the traffic was routed through the second one link, all the traffic that this user is going to generate will always go through as far as the second link, as far as this link to Bell is available. The traffic of this user will always go to the Bell ISP. So that's how source IP works. Another criteria is sessions. So the traffic is distributed based on the number of sessions that are configured through the member. So you will see now, if we select like sessions, you will see now below you have here like a graph that shows you what is the percentage of session or how many sessions you want each of the SD-WAN members to manage. So let's say, for example, you know for sure that your Rogers, or for my case, I will say, for example, if I know, for example, that my Rogers is performing well than my Bell, because my Rogers have maybe better bandwidth and maybe better SLA performances. So what I need to do here, for example, I will say, for example, if there are like 10 sessions that are entering in my FortiGate firewall, I would like, for example, 7 of them to be redirected to Rogers and maybe 3 to be sent here on Bell. So you see that in total, if you are getting 10 sessions, I'll be sending 7 on Rogers and 3 to Bell. So that's how you can decide depending on your environment. So another criteria here is spillover. So the highest priority member is used until bandwidth exceeds ingress and egress thresholds. So additional traffic is sent through the next SD-WAN member. So here also what you can do is you can decide which of the member has the priority, and for that you will need to define ingress and egress thresholds. Let's say, for example, the thresholds are given in KB per second. So let's say, for example, you are giving for we are still considering that Rogers is the beta, is getting the preferred SD-WAN member, for example. Let's say, for example, if ingress traffic goes beyond 50 KB per second and egress traffic goes, let me just say like 100. If you're having like 100 KB per second on egress traffic, then the additional traffic should be redirected to the secondary SD-WAN member. So this is how you define. If you go under spillover, this is how you are going to define the threshold for the priority for the member that is going to be the priority. So before you define this, eventually you will need to have a better understanding on the amount of or the average ingress traffic that you have on your network. So you will not just decide this value. You not just decide this value like this. You need to pay attention and take note of what is the average ingress traffic that you are getting on your network. At that time, you need to specify the information here accordingly. So that's it for the spillover. The fourth one is source destination. So this says traffic is divided equally. Sessions that start at the same source IP address and go to the same destination IP address use the same route. So in this case, what happens is that if the first traffic that was initiated that was initiated on this workstation to YouTube, if that traffic initially went through the Bell or through the Rogers ISP, that means every time that this source will initiate the traffic that needs to go to YouTube, that traffic will always go through the Rogers as far as the Rogers link is available. So that's it for source and destination. So for the first time, if at first when each of those workstations initiate a traffic that goes to a particular destination, if for the first time, if that traffic takes one of the ISP and the traffic is completed on that ISP, that means if you are using this option, it means all the time the traffic from that source to that destination will always go through that same link as far as the link is available. And the last option here is volume. So volume here is also like sessions. So before defining volume here, you need to know approximately, or you need to know the average volume that you are getting on your FortiGate firewall on the day-to-day duty. So here you also need to define. So by default here it is the word is set to equal to 1 but as I said, you can also decide maybe the volume here. Let's say you are taking a volume of 100 megabytes. If a volume of 100 megabytes is entering your FortiGate device, you can divide that 100 megabyte in 10 shares. Let's say you divide it in 10 shares. So you want, for example, that if 100 megabytes is entering your FortiGate, you would like, for example, Rogers to take like 60%. So you are saying, for example, you are giving six shares to this ISP, then you are giving 4 to this other ISP. So it means if you have 10 shares, your Rogers will be managing 6 shares, while your Bell will be managing 4. So that's how you need that's how you configure it. So these are the default load balancing criteria that are used if you don't define any SD-WAN rule here. So that's how it works. So that's why in the previous video, when we finished configuring all of this, you could see that the traffic was somehow shared on the two ISP without us deliberately or without us creating a particular rule. So that's it for SD-WAN load balancing algorithm. Let me just mention here SD-WAN load balancing algorithm. So now let's go on the second subtask, which is creating performance SLA for each of the SD-WAN members. So we can create performance SLA. So to create performance SLA, you come here on the performance SLA menu. So here you will see that by default we have like 5 performance SLAs that are already available. So the performance SLA here, the SLA are going to be like the value that we are going to use to determine whether a specific SD-WAN rule is better than the other. So those criteria will be packet loss, latency, and jitter. So talking about the performance SLAs, let's say for example, so as I said, these are default performance SLA that are available, and these are good starting points if you want to use performance SLA to evaluate the quality of your SD-WAN links. Let's say, for example, you want your SD-WAN link to send, let's say, want to send DNS request on FortiGate servers. So let's just double click on this one, default FortiGate. So this performance here, as I mentioned, the performance SLA, they will measure traffic based on the following protocols: ping, HTTP, and DNS. So you will select which protocol you want to evaluate and what is the server that you want to reach through that protocol. And here, what you need to do is you need to specify who are the participants. So the participants here are the SD-WAN members. So either you are just selecting here all SD-WAN member, or you can specify here, then you just select the SD-WAN member. So this is the same. And here you can define the SLA targets. So the SLA targets here are the value that you are going to put. So the value that you are putting here are not just random values. So these are value based on your environment and the ISP that you are using. So let's for example, let's just hit OK here. So let's hit OK here. Then we'll create our own SLA one performance SLA. So as I added, to explain, as I added those participants on this performance SLA, so in the next couple minutes, you will start see figures appear here. So these figures will related to packet loss, latency, and jitter for each of these ISP. So for each of these ISP, we will see what is the percentage of packet loss for each of them. We'll see what is the latency for each of them and what's the jitter for each of them. So as I said, let's just go and let's create our own personal SLA. So let me just say create. Okay, here I'll just say sample SLA. So let's say, for example, want to ping like 8.8.8.8. So as you see here, when you are creating a SLA performance, you have a probe mode. So either you are creating it to be active. It means this will apply based on the settings that the settings and the target that you define here, or you just want this to be passive. So passive means this will apply, but you will not be taken in consideration in the SD-WAN rules. Okay, so let's say, for example, we want to run a ping test on this destination. So all the SD-WAN members. So the SLA targets. So here, before defining the SLA target, you need to understand what are these values. So what is latency threshold? So before setting values here, you need to understand what is the latency and what is the jitter. So as you all know, latency is the delay or the delay or the time for data to travel from one source to destination. So that's what we usually call the latency. So the time that the data takes to go from the source to the destination. So depending on your ISP and your environment, you need to define a value here, depending on what type of traffic you want to access, because depending on the type of traffic that you need to access, there are some latencies that are defined to be good. There are some values that are defined to be good depending on the traffic that you want to go. Let's say, for example, a link that you want to use. Let's say a link that you want to use to do like gaming. The latency here will be different from a link that you want to use for video calls, or it will also be different for a link that you want to use for usual web browsing. Below 100 milliseconds is usually is generally acceptable for gaming and videos, right? Below 100 milliseconds, below 100 milliseconds is usually, this value is usually acceptable for gaming and videos. But if you have like 20 to 40 milliseconds, is generally considered as optimal. So if you want to consider a link to be an optimal link, you need to set here like 40 milliseconds to mention that you want, if an SD-WAN member have a latency that is below 40, then that SD-WAN member is optimal. Very, very good. But if it is like below 100, then it is still acceptable. As I said, it really depends on the type of traffic that you want to redirect using that link. And here we also have what is called the jitter. So the jitter is the time that let's say the time between two packets that were received. So if you are receiving, like, let's say you are receiving like 10 packets, the time between the reception of two packets, that's what we call jitter. So the jitter is like a variation in the time delay between the reception of two packets. So by default, 5 milliseconds here is a good value, but you can also like put it at 10. This, as I said, it really depends on your infra and the ISP that you are using. And also here you have what is called packet loss threshold. So if an SD-WAN member have a packet loss of, let's say, 2%, or let's say above 2%, you consider that SD-WAN as not being optimal. You see, so this value is also depend on your environment, the ISP, and all other criteria. So here is where you define what is the percentage that is acceptable for a link to be considered optimal. So for example, here we are going with 2%. So after the SLA target, we go here under link status. So the link status here is regarding these links. So this link that connect your FortiGate and the ISP. So here in this link, what is going to be the check interval? So the check interval here is the number of seconds or milliseconds that your FortiGate will ping, or let's say will check something like heartbeat to see if the ISP is up. So here by default is 500 milliseconds, so this half seconds. So we can leave it like this. Failure before inactive. So like, how many failure do we have to observe before considering that this link is inactive? So let's say, for example, if this link got disconnected, if we need to check each half seconds, how many failures are we going to check before considering that this link is failed? So 5 is also good. Same here for restore link after. So if the link is back again, maybe there was a power outage. So if the link is back again, after how many tries do we need to consider the link up? So we can also define it here as 5. So 5 here is also good. So we also check here update static route. Also update static route. So this is useful if, for example, you have configured static route using the SD-WAN SD-WAN zone. So here let's go with it like this. Now we hit OK. So you can see now that, for example, here on the default FortiGuard, as we enable we previously enabled the SD-WAN participant. As you can see now, here are the figure or the value that we have for each of the ISP regarding access to this FortiGuard.com website. So this was an HTTP protocol. We are using HTTP protocol here, and here we will create the one to use ping. So from here you can see that for each of them, these are the values that they have. So based on these values, you remember we did not change the value that were configured here, like the value here, like latency. You see latency here was 250, jitter was 50, packet loss 5%. So depending on your infra, like for example, let's say this is what we created for our own infra. So now you see the value that we are getting here. So any of the ISP that will get a value that is above the configured threshold, that link will be considered as not optimal and not preferable at the moment that we are going to use it. So remember, this is configured like this, but it will only apply if you define SD-WAN SD-WAN holes. So we define this. So as this other task was about analyze and adjust the value, so about packet loss, latency, jitter. So this one is to say, for example, when you've configured the performance SLA, what you need to do, for example, you need to generate traffic. So like when you configure your performance SLA, you need to generate traffic. You need to take like some few days to observe traffic on your network so that you can adjust this value accordingly. So for example, maybe after 1 week, we might decide that, okay, finally about this latency, maybe we can go for 150. Maybe we can go now to 150 because during the week, as we observe, we saw that latency was not that all the SD-WAN members were getting latency above 100 milliseconds. Or you can also decide instead to reduce, like for example here, you reduce and go back on 50. So you really need to take some few days to analyze the traffic on your network, then adjust these values accordingly. So now what we are going to do is to create one SD-WAN rule. So we are going to go on this one, create one SD-WAN rule to redirect social media traffic to specific link. So here what we are going to do is to go here under SD-WAN rules. So here we are going to create our first rule. So I'll call this rule SD-WAN. So let's say SD rule. So what I'm going to do is I'm going to create like 4 SD-WAN rules. So I would like to use one of each of the selections, the interface selection strategies that we have here. So let's say I'm creating a first rule that I'm going to call Facebook. Let's just say it like this. So the address here, what is going to be the source? So the source here is going to be our internal network. So the internal network here is this subnet. For people who saw the previous video, the internal network is this subnet here. We created a DHCP server here that is actually giving IP addresses to this subnet that we call here internal network. So the source here is going to be this internal network, and the destination here, either you are using as destination, either you are using application. Let's say for destination, either you are using an address, or you are using internet service. So ideally here, as Facebook internet service already embedded or included in the FortiGate. So what I'm going to use here is internet service. So from here, all I need to do is to search. So here we are going to search Facebook. Okay. So here, ideally, what you would like to do if you want to collect all the information regarding Facebook, so you should ideally here, I think you should select like all these services. So for me, usually I'll just select all these services rather than just picking Facebook. So I want to target all these services here. Then here, what I want us to check is in the outgoing interface, what is going to be the selection criteria that is going to be used. So here you have like 4 criteria that are available. You have manual, best quality, lower cost, and the maximum bandwidth. So let's begin with manual. So manual here means you are choosing to which interface you are going to send that traffic. So let's say, for example, you are using, for my case, for example, I want for my case all Facebook traffic to be redirected on the Roger SD-WAN link. So here manually I'm setting it to Rogers. Here, if I like, I can select here the zone. So if I select the zone, this means even though I'm selecting Rogers, in case the Roger link is not available, traffic will be redirected to the other member who is part of the test zone here. So this is it for manual strategy. You don't have any possibility to select any other information here. So we are going with it like this. So we'll hit save. So now I'll create another SD-WAN role. So let's see SD role for, let's say, YouTube. Address same internal network. So another way, instead of using the internet service, you can also go here under address. So under address here, you can create your personal address. So we are going to try it. So let's say you want to create an address to access YouTube. So here you are just going to say fully qualified domain name. Then you can say maybe youtube.com. So hit OK. So you just select your YouTube object here, right? So here I'm using YouTube. So here what we are going to use, so here we are using the address, the other one we use internet service. So here what we are going to do is best quality. So the best quality, as we said, best quality here, it means the quality will be the SD-WAN member will be selected based on a performance SLA that both SD-WAN members are participants, right? So it means here you can also decide which one is going to be the preferred interface. You see, you can also select what is going to be the preferred interface, what is going to be the zone that you want to use. Then here, what is the major SLA? The major SLA. So here you need to take an SLA for which these two SD-WAN members are participants. So based on the, so from here, for example, you can remove the interface preference and just let the major SLA to decide which of the two is going to be the preferred interface, right? So here you just select this one, and here what is going to be the criteria that is going to be used. So as we said, you are using the default FortiGate. And as you can see from this screenshot here, you can see what are the packet loss, latency for each of them, and the jitter. So here, what is the value that is going to be used? What is the criteria that is going to be used for the performance SLA that was created? So you can either use this one, or you can also use the sample SLA that we created. So remember, the sample SLA, we also added the two SD-WAN members as being as participant, right? So here you can decide, are you using the latency, jitter, packet loss? So here, for example, we are going to use latency as the criteria that is going to be used on this performance SLA to decide which of the interfaces is going to be the preferred interface. So hit OK. So that's it. So just creating a next one. Let's say we are going with Instagram. Okay, so internal network here. So here I'm searching for Insta. So okay, I'll select this one, the Facebook Instagram. So this is a service that is being proposed to me. So for the purpose of this video, I'm just selecting it. So here I'll go with lowest cost. So here also you are using the lowest cost here. You also decide what is going to be the zone that you are using. For example, this one, and what is going to be the required SLA target. Here also we are, maybe here we'll be using our FortiGate as the SLA target. So this is going to be the required SLA target. Then from here, we'll simply define, we'll also leave this information to decide which of the two links is having the lowest cost. So that is it. We see, just hit OK. So we have it so far. So as we decided to create the YouTube SD-WAN rule, you remember we did not select any of the interfaces to be the preferred interface. So if I double click again on the YouTube SD rule, you see here that we said best quality based on the better latency, the SD-WAN member that have the best latency on this SLA, measured on this SLA criteria, right? So based on the one on this information here, the preferred interface will be selected automatically based on the interface that has the better latency when this SLA performance is being evaluated. So as you can see that from here, we now have the preferred, as you can see, here is the preferred interface where you see this information here. This means that Bell is actually being selected as the preferred interface for YouTube traffic. So let's create the fourth SD rule. So I'll call this one general rule. So I'll just say general search. Let's say SD. Yeah, I'll say SD rule. SD rule for general search. Okay, general search. So here we'll still go with the internal traffic. Destination here or address, we'll just say all for here. So this is the general search traffic. So here we are going to take the maximum bandwidth. So we're taking the last interface selection strategy. So maximum bandwidth SLA. So traffic is load balanced among members that meet the SLA target. So what are the, so also here what I can do is I'll just select the zone. Then from here I will select the SLA target. So the SLA target here also I can select either the sample SLA, or I can select the default FortiGate SLA target as the target, because remember, ideally you should select the target that has the two SD-WAN members as participant, right? So imagine we request that the selected target, the required target should be this one and this one. Do you think the request here will be met if the interface has best performance both here and here, or if the SD-WAN member has the better performance on each of, or on any of the two? So I'll let you guys give me your response, or in the comment section tell me how do you think this will happen. Which interface will be selected? What are going to be the criteria for one of the interfaces to be selected, being mentioned that there are two SLA targets here? So I want to know your answer in the question, the comment section. Just hit OK. So what we are going to do here is, remember, as I said, the SD-WAN rules work the same way as firewall policies. It means, for example, if I select this rule, this internal, this SD-WAN general search, and I place it in the first position like this, this means as this is going from the internal network, all of the rules are going to from the source internal network to specify destination. But as for this one general search, as this goes to all destinations, it means if we put it at the first position here, all the other rules will not be considered, because this first rule already includes all the details that were mentioned in the other rules, right? So as you know, you should put the specific rules in first position and the general rules in the last position, right? So this is how you need to implement this. So now you can see that traffic is being, so for each of the SD-WAN rules, you will see now that based on the criteria and the members that we selected, you will see now for each of them, we know already which one is the preferred interface, right? So here I will just remove, let me just remove, maybe remove sample. I will leave FortiGate. Okay, hit OK here. Okay, so what next do we need to do after creating? So I guess what we need to do now is to test the traffic on client workstation and check the matching logs on the firewall policy to make sure, for example, that the traffic for YouTube is actually going through the Bell interface. So let's go. Or we can also directly, as we let's do it on the YouTube, on the YouTube rule. So what I'm going to do here, I'm going to force this. So instead of making it go through this interface, I would rather select here directly the Bell interface, or let's say the Bell or the Roger. Let's say the Roger here. So I'm selecting only one interface here, right? I will be selecting only one interface here. So I want all my YouTube traffic to be routed directly on the Roger interface, on the Roger SD-WAN. So let's jump directly here. Open this. Okay, let me generate some YouTube traffic here. Also generating some here. Then what we are going to do is we are going to jump on our, let me just double check that the traffic is actually ongoing. So all we are doing actually is on YouTube. All traffic that we are actually generating is on YouTube. So here on the YouTube, let me select another video from this end. Yep. Okay, so we now have YouTube traffic that is actually ongoing on all of our end users. So what we are going to do now is to jump here in logs, forward traffic. So from here, what we are going to do is we are going to search for the last maybe the last 5 minutes again. So let me just check. Okay, so we have a traffic for YouTube here. So if I double click, you see, for example, you have a traffic here for YouTube. So if I double click, you see the traffic is going through Rogers as we decided on the SD-WAN rules. So normally this is how you, let me just double check again, refresh. Destination, YouTube, applied. Okay, so YouTube, everything YouTube is going on. You can see now everything on YouTube is going on Rogers interface. You see, so everything now is being routed to the Rogers interface. So that's how it works. So guys, that is it. That's how you configure SD-WAN rules. So we saw so far how to create a SD-WAN zone, configure SD-WAN members. We also saw how to create performance SLAs here. So the performance SLA that you create here, you can use them in the SD-WAN rules to define which of the SD-WAN rule member will be used as the preferred interface or the preferred link for the traffic that you are ongoing. And we also saw that here, if traffic falls under this implicit rule here, so there are criteria here that you can configure. So you can configure criteria here to apply if ever traffic needs to fall under this implicit rule. So guys, this is the end of this video. I hope this was interesting for you. Please let me know in the comment section if you have any thoughts, any comment, any requests, or you can also suggest any topic that you would like us to create a video on it. So just let us know in the comment section. So guys, stay tuned. Let's meet in another video.